Check, check. 1 2 1 2. What's up? Welcome to CSMC 355. We'll be starting in just a minute. Check, check. 1 2. Check. Me. Hello. Check. Hello. Start here and just hope y'all are doing well.
Yeah.
Check, check.
Baby, don't make me spell it out for you. All of the feelings that I got for you can't be explained, but I can try for you. Yeah, baby, don't make me spell it out for you. You keep on asking me the same questions. Why? And second guessing all my intentions. Should know by the way I use my compression that you got the answers to my confessions. It's like I'm powerful with a little bit of tender and emotional sexual bender. Mess me up.
Welcome to CMSC 355. We're going to get started here in just 1 minute. I'll give you guys and gals just a minute to get on. Go ahead and get started.
Sometimes I'm mystery, sometimes I'm free, depending on my mood or my attitude. Sometimes I wanna roll or stay at home, walk in contradiction, get some factual and fiction. A little crazy, little sexy, little cool, little rough around the edges, but I keep it smooth. I'm always left to center, and it's right where I belong. I'm the random mind, and don't you hear in major songs, and I like that. I don't really give a fuck if I was just the only one who likes that. I never like to follow others around to chase the sun. Oh me, oh me, oh me, oh my. Oh me, oh me, oh me, oh my. Oh me, oh me, oh me, oh my. I like that. I don't care what I look like, but I feel good.
All right, let's go ahead and get started here. Hope you guys and gals are doing good. We'll get that down a little bit. All right, hope y'all are doing great. Welcome to CSMC 355. Today we're going to be talking about the observer design pattern, amongst other things. Hope y'all are doing well. Hit me up. Can't hear the music? Y'all hear the music, by the way. It's on very low right now, but you should be able to hear music. Is there any music? Let me know in the chat. Can you hear that? Okay, good. I thought so. All right. So we're going to get started here today. A few announcements before we get started. First of all, there's going to be a class activity, and it is going to be due today. So there's going to be a class activity. It is going to be due today. This one is one that you're going to turn in. Go ahead and hit up your buddies in text or chat or whatever, just to let them know that's happening so that they might join us, because they're going to want to turn it in. This is not a group one, this is an individual one, and this is something you're going to want to do today. It's due tomorrow by 3 a.m., but it's something that shouldn't take you very long at all. So I would recommend you try and do it during class today when you have me to kind of walk you through it. But anyway, just let your friends know that that is happening. Also, we have a deliverable next Friday. Who can tell me what I'm going to say about this deliverable next Friday? Let me know in the chat. What am I about to say about this deliverable next Friday? Let me know in the chat. See if you can guess what is in Davey's head. Demo. Close. That's a good guess, actually. Not the right one. Good guess, though. I like where your mind's at. Who else can guess what I'm about to say? Who can guess what am I about to say about the deliverable that is due next Friday? Come on, y'all. There's like 40 people. That is a very good guess. Prove that work was done on the Monday workday. Commit proof. Exactly, guys and gals. Commit proof, commit proof, commit proof. I want to see some commits from everybody in your group. And so committing is a key part of how you contribute as a group member to your group. What we need to do is, if your CI is only set up on a certain branch, you're going to probably want to set up multiple CI actions, continuous integration actions, so that you can get a commit, a build happening for any commit that anybody does on any branch. Okay, so you're going to want to be able to document those commits in your continuous integration kind of setup. That's the kind of thing you're going to be turning in. There's a question: what if the commit was done Monday night after 12 a.m. but still Monday night? Yeah, that's good. I mean, commits are good. All right, so commits are very important. That's what you need to do them. Next thing that I want to talk about is commit. Commits are very important to your grade and to this class. That is really what you're learning in this class, is how to work as a group. The only way that you learn how to work as a group is if you're actually working on the project. So make sure you're committing, because that is important to your grade and important to your experience here. Now, last time, I'm going to go to the music now, since we got to kind of into real lectures here. Last time we talked about SOLID, single responsibility principle, meaning each class does one thing. Open close principle, meaning we are open for extension, which is subclassing in object-oriented programming, but we are closed for modification kind of inside the class. Liskov substitution principle, where we want to be able to replace any reference to a superclass with a reference to the subclass and expect everything to go swimmingly. The interface segregation principle, where we're just trying to, make things less directly dependent upon each other and have things dependent upon maybe a common interface or some kind of intermediate thing, basically trying to make our system less tightly coupled. Another thing is the Demeter principle, where you want to know, you don't want to know about things that are not your friends. So you want to be able to access as an object, your own, fields and your own variables and stuff like that. You don't want to be too involved in a class that's way in some other package. You don't want to mess with their internals. You want to know about yourself, maybe your friends, but you don't need to know about somebody, some class across the world's business, if that kind of analogy makes sense to you. All right, so that was kind of last time. Today we're going to talk a little bit more about inversion of control, and we're going to do so by talking about the observer design pattern, a very important and super common design pattern, one of the kind of, I don't know, just fundamental design patterns to wrap your head around on kind of what is a design pattern. That's what we're going to talk about today, in addition to doing a class activity. So let's look at the motivation for the observer design pattern. Imagine that you have this application. All right. Here you can see we have a slider, and 2 entries, text entry boxes, and we're storing the same number in all 3 places. Okay. You could edit the slider and it would change the number in all 3 places. You could edit the text box below and it would edit the number in all 3 places. And you can edit the written out word below 5 and it would change the number in all 3 places. I want you to consider for a second, how would you implement this as a class? How would you implement this, well, as a set of classes? Think about how you might design this as a class. Think in your mind, meditate upon a gorgeous class diagram that you might create to represent this UI and the underlying data. And now let's talk a little bit about how maybe you should. So a naive way to do this would be to just essentially couple, like have no data model, but instead just like have an integer view, a slider view, and a text view, and have these things update each other. So if you change the integer view, it updates the slider view and it updates the text view. If you update the text view, it updates the integer view and the slider view. Who can tell me one problem that you could imagine with this kind of approach? Let me know in the chat, what would be a problem with this particular approach? Let me know what would potentially be a kind of a practical problem. Who can guess? What do you think a problem? Let me know in the chat. I don't mind waiting. Let me know if you want to hang out here for a while. That's fine. You are programming the same thing in 6 different ways. That is definitely a good comment. Anybody else got an idea about what could potentially go wrong? Good comments coming in. Thank you for that. That makes the class a lot more interesting for all of us when y'all comment instead of sitting there silently like a creeper. I know you're out there. I can see you on the stream. People number 2 through 48. It's fine to write things like I'm thinking. That just lets me know you're alive, which is great. Aha! Reckless Garage. It has a very nice answer. All of you have some really good answers. Actually, thank you for the comments and for coming alive. I really like the one by Reckless Garage. What if you want a 4th view? Now you have to like have a 4th view and you have to change all of these 3 existing classes, right? They all now have to update the 4th view, and the 4th view has to update all of these things. So this kind of solution really kind of annoying because whenever you want to make a change to it, you have to update all the existing code, and it's just, that's not great. So, and somebody's mentioning the stored data is redundant, and that is kind of getting at the same idea. Here is a basic observer design pattern, and it's a good way to think about these kind of problems. Okay, so instead of having these really tightly coupled solutions, you could just have a data model, which is, hey, the number. And then you can have things like get number and set number. However, your number needs to now tell people when it's updated, okay? So if somebody were to change the model, it's got to tell a bunch of people that it's updated. And how does that happen? Well, you have these things called observers, which is really just an interface. And the integer, slider, and text are all instances of observers. You register them with the model, meaning you add an observer. You say, hey, I'm an integer panel. I want to listen to you. So I'm going to add myself as an observer. Then whenever that model is updated, it will do this thing called notify, and it tells everybody that's observing it, hey, I've been updated. Now it's time for you to update your view. Okay, so add observer, remove observer is how these guys get registered. And then, as you'll see in the next slide, here's what happens when the model is updated. So when I call set number on the model, he executes a method called notify observers, and that says, hey, text panel, I'm updated. Hey, slider panel, I'm updated. Hey, integer panel, I'm updated. If you added another view and you registered it as an observer, it would say, hey, new view, I'm updated. Notice that this guy doesn't have to know about this guy, doesn't have to know about this guy. The model knows about everybody, but these panels don't know about each other. Okay? So this is how we go from the model changing to telling people that it's changed. The model is basically in charge of telling people that it's changed. Yeah, somebody's asking, I assume that text panel is not equal to text view. Looking back one slide to see if you, yeah, I mean, they are supposed to be basically the same thing, okay? I guess panel is the new version of things, right? So view is the old version of things. Text panel is like the new version, the new and improved version. That is based on a observer design pattern. Okay, a few comments about the basic observer design pattern. Again, we have a model. We have an interface for observers. And we have concrete observers 1 and 2, and there could be many different types, okay? It's the responsibility of the observer to register itself, meaning add itself to the model, and it's responsibility of the model to notify the observers when it has changed. It has this state changing method, which calls notify observers. See some questions here in the chat. So there's a question about, does this also implement a singleton design, right? No, it doesn't necessarily implement a singleton or require the implementation of a singleton. You know, it depends, like it's not necessary that there be a singleton here. You know, that is not inherent in the observer design pattern. Now, if you're talking about like getting an instance of the model, if you have no other way to get the instance of the model, you might make the model a singleton. That's true. But otherwise, they would need to know about each other, the observer and the model, somehow. But that is kind of an independent concern. We're just looking at the concern of how we register observers with the model and how we notify observers when the model changes. All right, great questions, great interaction. Y'all are awake. I like it a lot. Very nice. Keeping things interesting for all of us. You are the heroes of CMSC 355. Now, we are moving on to class activity. I hope y'all are ready for this. This is going to be fun for many of you and challenging for some of you. Here's what we're going to do. You will see in Gradescope that, go ahead and do this off screen so I don't expose anybody's grades. That would be bad. Let me pull up this assignment real quick. Show you what's going down here. All right. So here's what's going to happen today with the class activity. What we are going to be doing is we're going to set up continuous integration, but we're not going to do this with our class project, okay? Here's what you're going to do. You're going to find a project on GitHub that you want to set up for continuous integration, which just means building the project. We're not even going to worry about testing, just building the project. Excuse me. when you make a commit. I want you to then fork the project. How many, does anybody know? Let me know in the chat. What does fork mean? Anybody know what fork the project on GitHub means? Let me know in the chat if you have any idea. I can wait. Copy, clone, excellent, excellent. Yep, we're just cloning it, and it is really, it's cloning exactly, but it's also copying it into our own GitHub account. So it's just a cool way to share projects on GitHub. Like there's the original project. We don't want to mess with that. We don't want to screw up anybody else's project. So as John says here, you're basically starting your own version of the same project, which you can do whatever you want to on it. So that's a great answer. Good answer, people. All right, so you're going to fork it, and then you're going to set up continuous integration. How are we going to set up continuous integration? Can anybody tell me what we're going to use to set up continuous integration? Let me know in the chat. What do we need to do to set up, or what are we going to use to set up continuous integration? What is the thing on GitHub that we've been using to do that? Excuse me. And somebody's mentioning GitHub Actions, which is exactly the answer I'm looking for. There are many ways to do continuous integration. There's many independent services that interact with GitHub. We are going to use GitHub Actions because that's super easy. However, you can in the future use whatever you want for your real project, but for this assignment, we're going to use GitHub Actions. Once you've done that, you are gonna answer this question. Have you done this? You're gonna select yes or no, and then you're gonna put the URL of the project that you have done this for on GitHub, and the project must be public. This is the URL of your copy of the project, okay? Now, for those of you that are in class, I'm gonna tell you a little secret about my grading scheme here. The reason that you have to say yes or no, whether you've done this, is because we're going to be using auto grade. This is a class activity, so it's not not a project deliverable. It's worth less of your grade. So I want to have it automatically graded very quickly. So for most of you, this is how your project will be graded. If you say yes, I will trust that you have actually done it, and I will give you 100. If you say no, I will appreciate your honesty, and I will still give you a 75 out of 100. However, for a select few of you, probably between 5 and 10, I will use the URL that you put here, and I will check whether you have actually done whichever answer that you have said. And if I find that you have lied to me up here, I will give you a big fat 0. So I would recommend that you be honest on this, because there is a gambling chance that you will get a 0 instead of a 75, and that will definitely hurt your grade. So just be aware, answer this first question honestly, and you will do well either way, okay? I mean, 75 is probably not what you want to do, so you want to actually do it. But if you don't do it, make sure you answer honestly, and that would be the best way to go here. Okay, so so I want you to go ahead and start doing that, and I'm going to give you guys and gals time right here to do it in class. Please go ahead and start. For those of you that have any questions, I encourage you to hit me up in the chat, and maybe I'll go over an example of how to do this after the time runs out, but we'll see how many people have questions. There is a question about how do you browse other people's repository. Let me show you real quick. Check it out. You just go to GitHub and you can just do explore. Now, if I were you, because you guys are working on the Android Studio thing, I would just like search for, I would maybe just search for Android app right here, and then pick one of those, because you already know how to build those. But you can build anything that you want to. Somebody's asking, should we just clone our own repos? No, this has to be some other random project that is not related to this class. Do not do one related to this class. And as Justin York is asking, do we just pick a random public project? Yes, you are picking a random public project. I wouldn't just pick a random one though. You want to pick one that is like looks reasonable, because if you try and build one that's just completely random, then it may not build and it may just be a crappy project. So you want to pick one that looks kind of legit. All right, hit me up in chat if you have any other questions. Otherwise, we're going to be jamming as we work. About 8 minutes left here to do this. It shouldn't take you shouldn't take you too long. All right, let's go ahead and listen and
I've been working here. Monday it'll be a year. And I can't recall a day when I didn't want to disappear. But I keep on showing up, hell-bent on growing up, if it takes a lifetime. I'm learning how to be alone, fall asleep with the TV on, and I fight the urge to live inside my telephone. I keep my spirits high, find happiness by and by, if it takes a lifetime. I got too far from my race and I forgot where I come from, and the line between right and wrong was so fine. Well, I thought the highway loved me, but she beat me like a drum. My day will come if it takes a lifetime. I don't keep liquor here, never cared for wine or beer. And working for the county keeps me piss and clear. The nights are dry as dust, but I'm letting my eyes adjust, if it takes a lifetime. Well, I got too far from my race and I forgot where I come from, and the line between right and wrong was so fine. But I thought the highway loved me, but she beat me like a drum.
When I get home from work, I'll call up all my friends and we'll go bust up something beautiful we'll have to build again. When I get home from work, I'll wrestle off my clothes and leave them right inside the front door, 'cause nobody's home to know. You see, a hammer finds a nail and a freight train needs a rails, and I'm doing what I'm on this earth to do. And I don't thank God why I'm here where it hurts. I'm just lucky to have the work. Sunday morning I'm too tired to go to church, but I thank God for the word. When I get my reward, my work will all be done, and I will sit back in my chair beside the Father and the Son. No more holes to fill, and no more rocks to break, and no more loading boxes on the trucks for someone else's sake. 'Cause the hammer needs a nail, and the poor man's up for sale. Guess I'm doing what I'm on this earth to do. I don't thank God why I'm here where it hurts. I'm just lucky to have the work. And every night I dream I'm drowning in dirt, but I thank God for the word. And the day will come, and I'll find a reason. Somebody proud to love a man like me. My back is numb, my hands are freezing. What I'm working for is something more than freedom. I don't thank God why I'm here where it hurts. I'm just lucky to have the work. On Sunday morning I'm too tired to go to church, but I thank God for the word. I thank God for the word.
All right. Time is up. How did it go? Let me know in the chat. How did it go? Does everybody have success, or are we still having some problems? How'd it go? Let me know in the chat. Was it a disaster? Or did it go okay? Still building? Okay. Does anybody need me to do a quick demo on the screen, or does everybody feel fairly comfortable? Let me know in the chat. Like people are. Right, sounding like people are comfortable with this. I'll do just a quick demo. All right, let's explore GitHub. I will, let's see, what is a cool one? Android app. Here's what I would do. This looks like a Android app. Let's see how good it is. It looks like it's probably okay. I would go ahead and hit fork. Cha-ching, use that account. It will take a few seconds to fork. And now I have it forked. Then I simply go to actions, which is where I can set up my workflows. And it looks like there's already some stuff here. I'm going to go ahead and make a new workflow, which I think is just build with Gradle. Set it up. Commit it. Say, yeah, that's great. And probably, although I don't know, probably this will just run. See, it's starting to be queued, and it will probably just run and then be finished, and that'd be great. And I could watch it here. It's going to start in just a little while. So hopefully this runs, but that's the basic workflow that you would do. Hopefully that very quick demo gave you just a little yep, that gave you just a little insight into how to run it. But yeah, that's the basic steps. Okay, I'm gonna go ahead and move on now. Now we're gonna look at a case study of the Observer so you can get just a little bit better of an idea of how Observer works. Again, Observer is just a classic and maybe one of the most important design patterns for you to understand. It's really important to understand what a design pattern is, and so we're gonna go a little bit deeper into this one. And then once you understand what one design pattern is, the one thing about design patterns is once you kind of understand what one is all about, then it's a lot easier to understand other ones. Okay. So we're interested in an inventory system capable of keeping track of electronic equipment. An item of equipment records a serial number and a production year. An inventory object aggregates a bunch of items. Clients can add or remove items from an inventory. Various entities are interested in changes to these inventories. For example, it should be possible to show the items in the inventory in a list view, also in a pie chart, and other views, right? So it looks like a classic case where we're going to have kind of our model, which is all about our inventory, and a lot of different views on the inventory. So definitely the kind of situation which we might want to do use an observer. So here's kind of the basic set of classes that we might need. Who can tell me what this line right here means? Let me know in the chat. This line means, and you can say it in relation to inventory and item. What does this line mean here? Who can let me know what does that line mean there? Let me know in the chat what you think. Waiting for aggregation. That's good. That's a good word, and I think you probably know what that means because I think you're one of the students that's doing well. But I like it even better when it's said an inventory has lots of items, right? So inventory contains lots of items, right? That's kind of what we're looking for here. Great answers all around. Good work, people. These are the basic set of classes. Inventory has lots of items, and then we have pie charts and list views that tell us things about this overall inventory. Now, here's how we would relate the views to the items. Now, we don't want to listen to just every item because we want to know kind of about the overall state of the inventory. So the inventory is going to be the thing that we're observing. We have these two observers, pie chart and list view. We make an interface that these two things now implement, and item added or item removed methods calls these two things to be updated. How are these things, how does the inventory know to update pie chart and list view? Anybody tell me, how does the inventory know to update the pie chart and list view? How would that ever know about the pie chart and list Let me know in the chat, by the way. How would the inventory ever know that there is a pie chart or a list view or anything like that? That's along the right direction. Maybe. How would the inventory ever know about the existence of a pie chart or a list view? All right. So we're getting closer and closer. The key word here is registered. Who can tell me what registered means in this case? What does registered mean in this case? Think about it. Registered. Let me know in the chat. What do you think the word registered means in this case? Talking about the classes. Tough one. What does registered mean in this case? Anybody got a guess? Close, very close. Very close. Think about... Each view registers itself with the inventory's add observer method. So if you're a pie chart, you send yourself to the add observer thing. That makes the inventory know about that you exist. If you're a list view, you call at if you're a list view, you also could call add observer, and that lets inventory know that you exist. Now, inventory doesn't actually know that you're a pie chart or a list view. It just knows about things that implement the observer interface that exist. And then when an item is added or removed, it notifies everybody that has registered, meaning called themselves on add observer. Okay? So pie chart registers itself with inventory, meaning it calls add observer with itself. And now inventory knows that it needs to update pie chart. Let's see. What are we doing here? So I'm just making sure I understand exactly what so just one thing that you want to notice here is that we are actually doing notify observers with an item, and that is consolidating the add or remove item. Okay, so we're just doing a little bit of consolidation. We don't need to have both of these methods. We can just have like a notify observers, and then on the interface, it can tell it whether it's removed or added. Okay, so it's just slightly better code here, but this is not a super important point. We're just cleaning this up just a little bit. Now, we think about how this actually works. In practice, somebody calls on the inventory an add item, notify observers is called, and then item added is called on the pie chart and return, and then item added is called on the other observer, the list viewer, and returned. And now all of the observers know about the update to the inventory. All right, we're gonna go ahead and just think about this question for a minute. What's the difference between the observer design pattern and the pattern we use for the open-close principle, the strategy pattern? Okay, and that was the pattern where we had different strategies to print, like print into a HTML, print into a PDF, etc., etc. There are a lot of similarities. We have that interface, and we have a runtime choice of object. However, the difference in a strategy and an observer design pattern is that a strategy is really focused on choosing one thing, like only print to PDF or only print to HTML. An observer is focused on notifying lots of things, like tell all the views that things have changed. Okay, so besides that different, the strategy and the observer design pattern are actually not super different, but again, strategy is focused on one different strategy to do something. Observer is focused on notifying lots of people that are listening to me. So that's just some differences between the observer and the strategy design pattern. All right, so to summarize what we talked about today, observer is an object-oriented design pattern. Can anybody give me a really quick definition of what is a design pattern? What do you think a design pattern means? Who can explain in the chat, what do you think a design pattern is? Let me know in the chat. What is a design pattern? Come on, people. Method of structuring classes. A design pattern is a manner of solving a particular problem. Both pretty good answers. And they get at this idea that people have been programming for quite some time now, and they've been using object-oriented programming for quite some time. And the problems that you're going to encounter as a developer are not necessarily super unique. I mean, you may encounter one or two unique problems along the way, for sure. But in general, people have solved similar problems again and again and again out in the field. And so instead of reinventing the way of solving kind of a tricky problem, maybe you should consider, hey, is there a pattern that fits how I should solve this problem? And should I just reuse this solution that somebody else has spent a lot of time thinking through, and also that other people understand because everybody knows about the observer design pattern? Should I do it in this very well thought out and commonly used way, or should I invent my own like super hacky way that I just am inventing on the fly? So you should probably use the existing system. We're going to talk a lot more about design patterns just to give you guys some exposure to the different design patterns that are out there. We're not going to go over all of them, of course, because there's a gajillion of them, but we're going to give you a good handle on just the most common ones so that you are understand how to read and use some of the most popular ones. All right, so that's the class for today. I want to go ahead and open it up to any questions that you guys and gals might have, especially about the class assignment that we just did today. Let me know if you got any questions. I'm opening up to questions. For those of you that don't have any questions, you're free to leave. This is the end of the lecture for today. For those of you that do have questions, stick around, use Menti right here, and hit me up with your questions. So if you got any questions, hit me up in Menti. How do you know if the project is public? And I'm assuming that you are asking, how do you know if your own project is public, which I believe is the thing to ask. That is a great question. You can see that my build actually failed. Whoops. So I would need to choose another project in this case. Now let's look at this project. This is my project. There's a couple different ways that you can tell if it is public. Let's see. I think the easiest way is to go to settings, but let's check it out. Settings, and we can see manage access. Oops. Aha. This is a public repository, and this is how you can manage it. All right. So again, if you want to see if your own repository is public, you go to you go to that repository, hit settings, hit manage access, and you can see whether it's a public repository or not. Great question. Thanks for asking. Let's go to the next one. What do we do if we tried to fix the CI build on GitHub but found that nothing works? Well, there is many projects on GitHub. I promise you that you can find one that builds. I think people have even mentioned some in the chat that are probably working because they probably turned in theirs. And so what you need to do is just find one that builds. I would just go for another project, right? In a normal situation, if you were making your project, if you were setting up continuous integration for your own project, you would have to just make it work, and you would have to like fix the build so that it would build, and that's hard. But in this case, you can just change projects, and that's what I would recommend. But this brings up some of the problems that you would have in the real world if you're trying to set up continuous integration for a project. A lot of times on the first try, they're not going to build. You have to do things like change the build script or configure the continuous integration, and those are tricky things to do that you're going to have to figure out if you're ever in charge of setting up continuous integration. So this is giving you some good real world like experience. For our own project, I meant. And so I believe I answered this question because I showed you how to go to the settings in the repository, and you saw how to look up whether your project is public. Let me know, ask again if you're still confused about this. I'll do it again, but I think I answered this question. Somebody's asking, does the project have to build? A lot of build scripts for projects require setting up a lot of settings. Is it enough to create a generic build script that just runs a bit of bash for the assignment? It would be best if the project built. I haven't created the rubric for this project for this yet, so I hesitate to say that it has to build, but it really should build. And if you don't have a project that's building, just find another project. That's the easy way to go. Of course, you can try and fix that project. You're very right, and maybe you've had some experience with this, but you're very right to say that a lot of build scripts can require setting up a lot of settings. You're absolutely right. Good projects or projects that are run by smart people should pretty much just run the default build without any configuration. But that, of course, is not always the case, especially with open source projects. But yeah, they really should build. I would recommend you get a project that builds, switch projects if you need to. Great question. Somebody's asking, could you have multiple strategy patterns? If so, which is better, using multiple strategy patterns or using an observer design pattern? So these are really two different problems, in my opinion. You wouldn't have multiple strategy patterns. I mean, strategy is about, hold on a sec, let me just show you. All right, let's see. Yeah, here we go. All right, so the strategy pattern is really about implementing a single algorithm to do something, okay? Like you have some context, something going on, and you want to call a strategy like print, and you don't care which one is actually happening right now, like print to PDF, print to HTML, you don't care, you just want to print. You would not have like multiple strategy things like in order to implement an observable case. The observer case is just for the time that you want to tell different people that things have been updated. So observer patterns really just notify people that things have changed. Strategy patterns are actually doing something, right? So it's kind of two different things, right? A observer is just notifying somebody, hey, things change, you should update your UI. The strategy pattern is like, hey, use your strategy to get this job done. So it's really two different use cases. Great questions today. All right, we're running out of questions. I'm going to get going here in just a second. If you have any more questions, hurry up and put them in the chat here. Otherwise, I'm going to hit the road. And like nobody's having any more questions, you're welcome. Thank you. I will see you guys and gals on Monday. Take it easy. Have a great weekend. See y'all later.